final exam review, page 4. Solve the equation log of 2 plus x minus log of x minus 3 is equal to log of 2. All right, we'll just start flexing our logarithmic muscles, if you will. So when I subtract, that means I divide the arguments. Okay, that's a legal move. And that's equal to log of 2. We know when the base isn't written, we have the common logarithm of 10. So I would write 10 log of 2 plus x over x minus 3 is equal to 10 to the log of 2, where both of those are exponents. You could even use the one-to-one property and be done with it if you wanted to. If you started in the beginning, that you have logs on both sides, so just set the arguments equal to each other. So I'm left with 2 plus x over x minus 3 is equal to 2. I'll put a 1 underneath it just so everybody understands cross product. So that's 2 plus x, because 1 times 2 plus x is just 2 plus x. And then 2 times x minus 3. All right, so off to the races. All right, don't mess up. Okay, make sure you're nice and smooth and get the right value. Okay, also plug it back in, make sure there's no negatives in your logarithm, and all the domains look just fine. Okay, over here, find the period. The short form is that the period is equal to, 2 pi divided by b, and I believe the general form as written is a sine of bx minus c. Okay, so in our case here we have 2 pi divided by b is 1/4, and when you multiply by the reciprocal, okay, you should just get 8 pi. Okay, so they're really just testing if you know how to handle a denominator like that. Okay, the phase shift, so that's a word I haven't really used. They're just asking you, okay, how much has this thing moved to the right? So if we were to graph this, the first thing my students would do is they would take 5x minus pi over 6 is equal to 0, and 5x minus pi over 6 is equal to 2 pi, because the period of sine is 2 pi, and it starts at 0 and ends at 2 pi. What they're asking for a phase shift is just where does it start? Where does it go? So they're really just asking you to solve this thing. So if you just solve this, you'll get the correct answers. So 5x is equal to pi over 6, and x is equal to pi over 30. So they're just, so the phase shift, okay, is asking you where does it start? Where does it start after you shift? Okay, that's the question there. Okay, assume theta is an acute angle in a right triangle. I will do that right now. So I don't know. Looks like a right triangle to me as soon as I mark it. Okay, we'll put theta there. They told me that cosine of theta is equal to 2 over 3. And I know that SOHCAHTOA is adjacent over hypotenuse. So the hypotenuse is 3, and the guy adjacent, the guy next to this angle, is 2. We know a squared plus b squared is equal to c squared. So that means 2 squared plus something squared, right, is equal to 3 squared. I'll just call it, you want to call it y just because he's there. Okay, fine. We see that y squared is equal to 9 minus 4, or y is equal to radical 5. It's an acute angle, so 2/3 is just fine. So we'll use radical 5 and see if that works here. That's the obvious choice. So we'll say y is equal to radical 5. Next, we know that tan of theta is equal to SOHCAHTOA, opposite over adjacent. So opposite is now root 5, and the adjacent is 2. So your answer should be root 5 over 2. Find measures of two angles, one positive, one negative, that are coterminal with pi over 6. Okay, so let's go ahead and draw our axes there, and let's just put in a guy who's at pi over 6 here, and they want us some coterminal angles. So they want you to swing the door around this way, and one positive and one negative, and then we'll also swing the door back around the other way. So how do I do that? How do I get around the unit circle? That's right, you guessed it. We're just going to add 2 pi and subtract 2 pi. Okay, so pi over 6 plus 2 pi is basically asking you if you can add fractions. So pi over 6 plus, what is it? Make sure I know how to do it, right? 6 times 2 is 12, 12 pi. Okay, so that gives me 13 pi over 6. So that's the positive one. Then I'll take pi over 6 and I'll subtract 2 pi, swinging the door the other way. So that's pi over 6 minus 12 pi over 6. And if you do that madness, you'll get a negative 11 pi over 6. Okay, let's keep going. Let's see, find the exact value of 210. So I don't like degrees, so I'll take the pi out. No, I won't. I want to put the pi in. Excuse me, over 180. So I'm really just have to reduce 210 over 180 and then multiply it by pi. Zeros is the middle school trick. 21 divided by 3 is 7. 18 divided by 3 is 6. So 7 pi over 6. Where is 7 pi over 6 in the unit circle? Well, let's get this straight. So that's pi over 6, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Oh, there he is, 7 pi over 6. And if you recall, that position there, I believe, would be a negative root 3 over 2. And he's downstairs, so that's negative 1/2. So if you want cosine of 210 degrees, you're really asking for cosine of 7 pi over 6. And unit circles masters know that's the negative guy. That's the x guy. That's 7 pi over 6, which gives me a negative root 3 over 2. Remember, you must be a unit circle master. Okay. I'll put that in there. I don't know what I'm doing there. Okay, here we go. So give the exact value of 240. Oh, where in the world is 240? Again, I like to use the unit circle. So I'm going to put the pi in. Okay, so that's pi over 180. Again, they're just asking me to reduce 240 over 180 and then multiply it by pi. High school, middle school trick. 24 and 18. Oh, who's the best? So I don't know, 6 gives me a 4. 6 gives me a 3. That was a good one. So 4 pi over 3. So I'll do my unit circle, and around they go. Pi over 3 is a tough one. Pi over 3, 2 pi, 3 pi, 4 pi over 3 is way down here. So that's the negative 1/2, negative root 3 over 2. Again, you've mastered your unit circle. This is not a problem for you. Cosecant of 240 is equal to cosecant of, what did we say now? Pi over 3, 2 pi, 3 pi, 4 pi over 3. Now be careful here. You got to be careful. So cosecant is what? 1 over sine of 4 pi over 3. And we know that sine of 4 pi over 3 is the y guy, is 1 over, careful now, root 3 over 2. And if you multiply by the reciprocal, you get 2 over root 3. And the madness still hasn't ended because you might have to rationalize this guy. So we'll multiply by root 3 over root 3, some form of 1 that doesn't change the value of your number. And root 3 times root 3 is just 3, so your answer should be negative. Don't forget the negative 2 radical 3 over 3. All right, cotangent of 3 pi over 4 is just ridiculous. Here we go. So we know it's already in the nice form we like, 3 pi over 4. So what is cotangent? That's equal to, you could do it several ways. Let's do it with, well, I don't know. Cotangent, tangent, I guess that's what you see. So you'll see 1 over tangent of 3 pi over 4. Now be careful, this can get kind of messy here, but I'll do it. Let's go ahead and do it. So unit circle, 3 pi over 4, pi over 4, 2 pi, 3 pi. So 3 pi is here. You know that's what? Negative root 2 over 2, root 2 over 2. So tangent of that guy would, oh, it's easy. It's just negative 1. What am I talking about, right? Tangent of that guy is just Don't make me write. It's just y over x. So I'll just write -1. So you just get -1 there. Yeah, I was just testing to see if you knew what I was talking about there. I knew it the whole time. Okay, evaluate cosine of 3 pi. Let's see it. Okay, I don't know. Pi, 2 pi, 3 pi. There you go. That's what? -1, 0. So cosine of 3 pi is equal to the x guy, which is -1. You just must be a unit circle master. Nothing left to say there. Okay, video number 4 or 5. Which one am I on now? Anyway, it is done, and I'll see if I can even get one more in. All right.